Welcome back to exercise 1.2 of chapter 1 real numbers. So what's the first question here? Express these numbers into the product of their prime. So we already know what are the prime numbers that cannot be further divide, right? We cannot open those numbers. That's the end of the numbers, right? So first question is 140. How can 140 open as? It comes in two table. Yes, it does. We should always take the minimum number here. If the small number doesn't come, then we can increase the number. If 2 doesn't come here, we can take 3 or 4 or 5, so on. But 140 comes in 2. Let's take 2 first. So 2 7s are 14, then 0 as it is. Then 2 7s are 14 and 0 as it is. Now 70 comes in two table. Yes. 2 3s are 6, 1 remaining here. 2 5s are 10, right? 35 doesn't come in two table. Does it come in 3? No. In 4? No. So what's the next biggest number is 5. So 5 7s are 35. 7 comes in only 7 table. 7 is also prime number. 7 1s are 7, which you should do until we get the number as 1 remaining. So what are the factors that we got here are 2, 2, 5 and 7. How many 2's we have? 2. So 2 square. How many 5 we have? 1. So 5 into 7. Right. So the next number is 3825. 3825. Does it come in two table? No. We have the odd number in the end. So whenever there is an odd number in the end, it doesn't come in two table. So the next number is 3. 3 1s are 3. 3 2s are 6. 2 remaining here, right? 8 minus 6 is 2. 3 7s are 21. 1 remaining here. 3 5s are 15. Then we take 3. 3 4s are 12. 3 2s are 6. Then again 7 minus 6. 1 remaining here. 3 5s are 15. Now the next number doesn't come in 3 table, so we are taking 5 next. 5 8s are 40. 42 minus 40, 2 remaining again. Then 25, it becomes 25. Then 5 5s are 25. So 5 1s are 5 again. 3 remaining here. 5 7s are 35. So it becomes 17. 17 is also an prime number, so it doesn't come in any other number. So 17 1s are 17 as it is. What are the factors we got? 3, 3, 5, 5 and 17. How many 3's we have? 2. How many 5 we have? 2. How many 17 we have? Just 1. So give it as it is. Next question is, find LCM and HCF of the following prime by prime factorization method. So what's the prime factorization method? It's nothing but fundamental theorem of arithmetic. We need to open the numbers. So let's moving on to the question here. We have three numbers in the first sum, that is 12, 15 and 21. Let's take 12 here. How can we open 12 as? 2 into 2 into 3. 2 2s are 4, 4 3s are 12. How many 2's we have? 2. So it's 2 square. How many 3 we have? Only 1, so it's just 3. Open 15 now. 3 5s are 15. 21 as 3 into 7. These are all the prime numbers which cannot further open as. So LCM. What was the LCM? We need to take those number which has the highest power. A power max. Do you remember that I told you in the previous videos? Right? We should take those numbers from each of these. If there is no max, then 1 is sufficient. So what's the max number in this? 2 square. 2 square. Then 3 power 1, 3 power 1, 3 power 1. So it's just 3 because none is max. 3 power 1 is max. So it's 3. 5 1, 7 1. We should take all the odds. So multiply all of this. You get the answer as 420. So LCM of three numbers are 420. HCF is any number that comes in all of these three. 3 here, 3 here, 3 here. So the HCF is 3, highest common factor. Now the next numbers are 306 and 657. 306 can be opened as 2 into 3 into 3 into 17. Now how many 2 we have? Only 1 2. So 2 power 1, that is 2. How many 3's we have? 3. 3 power 2, that is 3 power 2. 17 1, 17 1. Now 6 5 7. 3 into 3 into 73. 75 also is an prime number which doesn't come in any other number, so it is kept as it is. How many 3 we have? 2. 3 power 2. 73 1, 73 1. So let's take the LCM. How many 2's we have? We have only 1 2 here. There is no 2 here. The power 1 is the highest. Let's take the power 1. 3 power 2 here, 3 power 2. Both are equal. It's just draw. Just take 3 power 2. 17 again 1, 17 again 1. 73 1, 73 1 alone. So the LCM of 206 and 657 are 22338. Now the HCF is highest common factor. 2 common in both? No. What's the common thing here? We have 3 square common. So 3 into 3 is equals to 9. HCF is 9. The next question is, check whether 6 power n can end with the digit 0 for any natural number n. So given number is 6 power n. So how can we write 6? 6 can be written as 2 into 3 power n. The prime factors here are 2 and 3 only, right? How can we write 6 as 6 into 1, 1 into 6, 2 into 3. That's it. No other way to write, right? So to end with 0, we need 5 and 2. Why do we need 5 and 2? Because 5 into 2 equals to 10, right? So the 0 is at the end, right? That is what he's asking. What does he need? 0 at the end. So at least it should be 10. It can be 20, 30, 40 or so on, but least thing should be 10, which cannot be satisfied by the 6, because 2 into 3 is not 10, and 6 cannot go any further to give you 10. So 6 can't end with 0. 6 power n can't end with 0. We need at least 5 or 2 to make something that has 0 at the end. So 6 power n can't end with 0. Next question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So what were the composite number? Just revise it again. Any number that has more factor than itself and 1. Okay, it should have at least 2 numbers that can divide, like 6, right? It is 1 and itself, but we have more 2 numbers that make 6. So 6 is a composite number. At least we should have 2 numbers, so its product can make a number known as composite number. Let's look at the solution we have. Given numbers are 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay, so what are we going to take? We have plus here and multiplication here. Let's take 13 common from this. So what's remaining? If we take 13 from this, let me just circle it to give you a proper explanation. If we take 13 and 13 common, so the remaining things are 7 into 11 from this one, and if there is nothing here, then it should be 1. So that is what we wrote here. 13 taking common, 7 into 11 from this one, and 1 from this. 7 into 11 from this, 1 from this. Similarly, if we take 5 common from here, because at the both side of the plus we have 5 here and 5 here. Let me just circle it. 5 here, 5 here. Let's take this 5 common. So what's remaining here? 7, 6, 4, 3, 2, 1 plus, if there is nothing here, comes 1 again. We take 5 common. 7, 6, 4, 3, 2, 1 plus 1. Let's sum it up. So what will we get? Let's consider whole of these as k and whole of these as L. Just suppose. So if this is whole k, then it can be 13k. If this is whole L, then it can be 5L, right? So the value of k is 78 and the value of L is the product of all this plus 1. So as the given numbers can be written as the product of 2 numbers, which is 13k and 5L, then they are composite. As I have already said, apart from itself and 1, it should be written as the product of any 2 numbers. So this 13k can be written as I'll just write it here. 13 into 17, 8, which is not itself and 1. Similarly, this 5L can be written as 5 into 1009. So these two numbers are neither 1 nor the given numbers as itself, right? So these are composite numbers. So the next question is, how will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? Just as the previous question, it is quite similar. Let's look at the solution. What we have, 17 into 11 into 2 is the one number. Another number is 17 into 11 into 5. So we have 17 into 11 here, 17 into 11 here, to the both side of the plus. Let me just underline it. 17 into 11, 17 into 11. So let's take the 17 into 11 common. After taking 17 into 11 common, what's the remaining thing here? 2 and 5. 2 to the left of the plus and 5 to the right of the plus. Taking 17 into 11, 17 into 11 common, we get 2 plus 5 remaining. Let's sum it up. 17 into 11, center is the product thing. 2 plus 5 is 7. So 17 into 11 is 187 into 7. Again, we got two numbers that are not 1 and itself. So these numbers can also be considered as composite number. Can have two products apart from 1 and itself, known as composite number. The last question of the exercise is, which digit would occupy units place of 6 power 100? So what's the unit place? We have, let's suppose a given number 1, 2, 3, 4, any number. So this is units, tens, hundreds, thousands, and so on, right? So unit place is the one which comes at the end to the right. So what's the question here? We know that 6 power 1 is 6. We need to go till 100, right? 6 power 2 is 36, as 6 into 6, 36. 6 power 3 is 212. 6 into 6 into 6, 6 is a 36. 36 is a 216. So on with the 4 and the 5, we got these numbers. So notice one thing, that at the end of this number, what we are getting? 6 at the unit place, 6 at the unit place, 6 at the unit place. In all of these numbers, we are getting 6 at the most right, which is the unit place. So when we are getting the 6 at the unit places, then to the power of 100 will also be the 6 at the unit place. It is proved. We see that 6 power n for any positive integer ends with 6. N can be any number from 1 to so on till infinity. Unit digit is always 6. So 6 power 100 will also be 6. That's the end of today's exercise. Thank you.